Alright, here we are. So, welcome to my channel. I'm Matt Heffernan, and I'm going to be talking today about the XCI game engine that I'm developing for the Commander X16 retrocomputer. I've been posting about it on Facebook within the Facebook group, and within there's a Discord room for it. I've mentioned it in there, and there's also the Murray Brothers forum for the 8-Bit Guy and Geek Pub. Of course, David Murray, the 8-Bit Guy, is the mastermind behind the whole thing, and this has inspired me to sort of reach back in my past and come up with developing games of the kind that I enjoyed back during the 8 and 16-bit eras when I first started using computers. My favorite type of game, which came about in sort of the late 80s, although it had certainly predecessors, was the point-and-click adventure game. That evolved out of the more text-driven adventure games from the 70s and early to mid-80s. And the company Sierra Online started going from requiring the user to have to type in everything that they're doing to just being able to have sort of a contextual mouse pointer where you could click on different things and it would open it up. And then that evolved into other types of games like Myst and a lot of the even modern point-and-click mystery games that are very popular among casual gamers. And that's what I'm trying to create here for the X16. We have the capability, the graphics capability. We have an enormous abundance of RAM for an 8-bit platform. And so I created this. I call it XCI, Extremely Compact Interpreter. So what it basically is similar to the game engines of the past for this type of game. It has a bytecode that is interpreted while you're playing the game that dictates what you see in the game and what items there are in the game, how you interact with it, and so on. It's a very and then before you're actually playing the game, you can, if you're the developer of the game, you have a sort of a high-level language in which you can define these games. And what I wanted to do is create a language that non-programmers would be comfortable using. And so it doesn't require BASIC, doesn't require any assembly or anything like that. I created a basic scripting language, and we're going to go over in this video very briefly how you do that. The first thing to do is to go through the GitHub site for XCI. You can see the URL up here, and of course it'll be linked in the description. What you're going to want to do first is go to GitHub and clone this repository. You could just download the releases, but I definitely recommend cloning so you can actually see for yourself how the actual engine was created, and then you get all the files all at once, and you can stay up to date much more easily. So if you click on the clone or download button, you can see here you'll get the URL that you can give to Git for cloning. So I'm just going to copy that to the clipboard, and I'm going to go in here in my terminal, and I've created a little temp directory here where I'm going to do a git clone and then paste that URL right in there. There we go. And it's just going to download all that off GitHub, and there we have it already. So we take a look at what's in there. Of course, it's by default creates a directory called X16-XCI, so we go into there, and we can see here the same files. If we look back behind here in the GitHub, we can see those same three directories and then a bunch of files right there, including the readme.markdown, which you can see here going back to the web page is the main documentation for the page. This is a fairly substantial document, and I'm not going to go through everything. You can see here I'll sort of skim through that right there. It's very big. I've got a table of contents for it. I'd highly recommend reading through that to really understand what's going on with this engine, and if you're really interested in creating your own game. But what I've got with this is an example game. And you can see here of these directories, there's a directory called example. if I ls into that, I can see here, this is basically the source code and data for the game. And we can see a lot of things that are like .xci files. And that's the main language that these games are defined in. In fact, the very main one is this mygame.xci, which, see, right there. Now, I've hopefully got that open right over here. Mygame.xci, and this is it. This is sort of like the main, sort of the main module, if you will, of the game, and it just sets up the very highest level configuration parameters for the game. You give your game a title, you put in an author. That's sort of both of those fields help to uniquely identify what your game is. And then there's certain top-level configuration files that you define. You define your mouse cursor, and then the game zones. And we'll get into all of that in a minute. But so that's sort of how we start. You can see it's just a very simple text language. Not a lot of fancy constructs. There's not a lot of special characters like you'll see in most high-level modern languages. So it's really more of an assembly language, but an extremely high-level assembly language, because you're just assembling this bytecode that gets interpreted. But anyway, so how do we actually do that? So going back here to the top directory, we can see we've got the other directories are engine and SDK. Now the SDK is stands for Software Development Kit. And if we look in there, we can see a bunch of C code that's in there. What we're going to want to do is just build that. And if you're in a GNU style environment, if you're in Linux or Mac, everything is all taken care of. All you need to have is GCC. If you're running Windows, you can certainly do this with Cygwin, with MinGW, whatever you have. I did build a Windows executable using MinGW, and I've tested it on a vanilla Windows 10 box. It works fine. But I'd still recommend cloning and building yourself, because it's extremely simple. All it is once you have, make sure you have the whole GNU, GCC and make and everything like that installed, and then all you have to do is type make, and boom, there it is. You've built the whole software development kit. And if we ls again, we'll see this XCI.exe, and that's a program that executes on your host computer, on your development platform. It's an extremely simple, very plain vanilla C application, and you could compile it for anything. You could easily compile it for something like a Raspberry Pi, an old 32-bit operating system, even a 16-bit operating system. A very old computer could easily run the software development kit. Of course, so whatever your daily driver is, I would recommend building for that, and it just makes the development process easy. It's certainly not intended for you to develop these games on the X16 themselves. This is certainly a cross-development type environment. So there's the SDK, and that's how we're going to actually build our game that we create. But before that, we have to also build the game engine. And now we'll go back in here and go into the engine directory, and here we're going to see a bunch of assembly language. Now this is assembly language for the Commander X16. It's a 65CO2 assembly language. And like also here, we just have a make file, and we use GNU make to make it, and boom, it's done. And now we have this xci.prg, all in caps, which is important. The X16 really only is happy with file names that are in all caps. And that's the program that the X16 is actually going to run. Now, by itself, it doesn't do anything, because it has to have an actual game to execute. This is strictly the bare bones engine at this point. To actually build the game, we'll go back again. Now, I have the example game in here. Now, this example game, if you've seen the videos that I've posted before, I've posted a full walkthrough of the game. It's a very simple, very small game. It's not meant to be actually entertaining. It's just a means to an end of for me to develop this engine, and for you to see how to build your own game, and some of the different strategies and constructs and things that you can use when you're doing this development. And you can see how very simple it really can be. It doesn't take a lot of work to build a game. Once I had the engine in place, the game, once I had to start filling out the rest of this game to get in all the things I wanted to get in there to test everything, it went together very quickly at that point. So what we're going to do, if I now go back, remember I ls back into here, and I can see all these different types of files. Most of these are the direct sources for the file, and we'll get into what these different files are for in a minute. But all we have to do to build that is we got to call that SDK host executable that we built before, which will go up into the SDK. That's xci.exe, and it only takes one argument, which is the main configuration file, which is mygame.xci. And we run that, and that's it. It's done. It goes real quick. There's not a lot to it. Again, this is meant to be very small and compact, at least by today's standards. By 8-bit standards, it makes it a giant, unwieldy thing, but we have a modern 8-bit computer that we're targeting now, which is pretty cool. So here we have now a whole bunch of .bin files, again in all caps, which is a good indication of what it's intended for, which is the X16. So we can see over here there's a main.bin, and that's what that XCI.prg program calls. It's going to load that main.bin, and then that, from reading that main.bin in, it's going to go through and load in all these other bin files, either immediately at the start of the game or later on when they're needed. Because obviously it can't fit all of these in RAM at the same time, and as we'll see later, there's the construct of zones, so that only one zone is loaded into memory at a time. And we can have a whole lot of zones, 256 different zones. So we can have a really super huge game. And, oh, hey, look, there's Stephen Alexander. If you don't know him, he is the main guy behind Infamous Adventures. He also makes games like this, but for modern platforms like Steam. Just a little shout out to Steve there. He's a good friend of mine. Actually know him outside the internet, like real life. I've met him. We're from the same town. So... and anyway, right, yes, okay, go away, Facebook. Yeah, now go away. Anyway, back to where we were. So, all right, yeah, Steve is active on Facebook right now. So we're going to see how we build all these different games, what they come from, what they mean. But at any rate, there they are. And now let's go back and look at the actual source. So mygame.xci, as I said, this is the main file. This is what we passed in to that SDK program. Okay, just go away. And the first configuration file it loads is a palette file, which we called mygame_pal.hex. Now, this is not. This is in a different language than the file here that we see. It's not this XCI configuration file. It is just a plain hex file where we are just defining binary data with ASCII encoded hex. And we can see here what I have for this game, which I had for my previous game, Chase Vault. If you check that out on YouTube, also. I created a hex file format where I can insert comments into it to help better separate it out and understand what I'm seeing. So for XCI, we want to create a basic 16 color palette. I have a full 256 color palette here. That's just for illustrative purposes. You can read more about that in the README. But this first line right here, this is the main default palette for the application. And if you've been playing with the X16 for a while, you'll recognize that as the actual system default palette. I've chosen to make this example game just use the plain vanilla default palette, just so that you can see what you can do with that when you start adding that tiles and sprites using that palette on top of bitmaps that use different palettes. As we can see here, once we get into the game, when we load up these different game levels, they'll each have their own custom 16 color palette, and you can combine the sprites and you can have sprites and tiles using any of the palettes in there, including the default palette. And there's an all black palette. The last one's always all black. And then we have other palettes for other special purposes that we'll get into. And so anyway, that's how we define our palette. The tiles.hex. So these are all the tiles that go in the game. If we look back just for a little context here on our main README file, you can see the memory map that we have here. The main RAM, the actual the basic user space of the X16, that's where we keep the XCI engine code and the top level game data, basically the stuff that we're loading, those .bin files we just built. Those are going to, the top level ones are going to be loaded in at 6000 hex, and below that is going to be the actual engine code. It all fits within that. It's actually pretty small. It's like 16K of code for the engine itself. And then up in banked RAM, this is where we have the data for the different levels of the games, the other bin files that we just sort of dump into here. And then at the very top end of the basic level, the basic configuration for the X16 has 64 banks, 64 8K banks of RAM for 512K of banked RAM, and those top three I use for special purposes, which you can read more about in the README file. But then in the VRAM, I have bank 0 split up between the bitmap. The bitmap sits on layer 0, which is the bottom layer, and it's a 16-bit 320 by 240 bitmap, although in practice for the levels it's only 320 by 200 to keep it smaller and to have space for a little text area, which we'll see later. Then we have a tile map. We use 8 by 8 tiles in this for this engine, so you're going to have a 40 by 30 tile map covering the screen, and then the actual tiles themselves, as we'll see up here in the description. Using up this much VRAM for the tiles means that we can have up to 720 different tiles. And then the bank 1, that whole 64K is dedicated just to sprite definitions. So the sprites are, unlike the tiles, are 16 by 16. And of course the X16 supports 128 simultaneous sprites, but within VRAM we're going to have 512 different sprite frames that could be loaded into any of the sprites at any time. And that will become very useful, where we can do lots of overlays and animations between using these tiles and sprites that are sitting on top. So as I said before, the bitmap is going to be in levels layer 0. The tiles are going to be in layer 1, and of course sprites sit on top of both those layers, which is just basically how the X16 works. So going back, here we can see another hex file, just like with the palette, for defining the tiles. Now, since all of our tiles and sprite frames are 16 color, 4-bit per pixel binaries, then we can define each pixel in terms of a single hexadecimal numeral. In other words, just a single character from 0 through 9, and then A through F. And those represent the actual colors. So we can see here, I create the first tile, which I'd highly recommend. You want your first tile 0, because that's what's going to be by default plastered all over the screen, is to be fully transparent. It's just all color 0, which is black or really transparent, just not visible. And then I have the second tile is all white, and color 1 is white. Now, it's kind of hard to actually develop graphics just in text like this and trying to wrap your brain around what these numbers relate to as colors. And you can see here with this font, it's taller than it is wide, so everything's sort of stretched up. So what I created here was a spreadsheet, and now we can see here what a plain black tile looks like, the plain white tile, and then some of the other tiles. And we'll see how we use some of these tiles later on. But I just basically sketched them out. I put the palette over here so I can see here's the default palette, and we can see 0 through F are the indicators for which colors represent which hex nibbles, as it were. So yeah, like we get something more colorful here, like the Commander X16 butterfly logo. We can see we created a little version of that, and how all the different colors that are involved in that. It's got a black background, so most of them are zeros, but then we've got these other little numbers mixed in there to represent the different colors. Very basic. Now the sprites, of course, was the same sort of deal, except now the sprites being 16 by 16, we got bigger things. For the very first frame, I just have the initial mouse cursor. This is the basic mouse cursor that's going to be used. The mouse cursor is just another sprite. The X16 reserves the sprite 0 as the mouse cursor, but what we can do is put different frames into sprite 0. But by default, I used frame 0. And we're going to see here, if I go back to the spreadsheet, that's what it looks like. Then I've got some sprites for this avatar. You can see I've just recycled the avatar from Chase Vault. I was not feeling too industrious. But now here we see some of the alternative mouse cursors that I created. And you can see they each have this little tiny pointer in the upper left corner, because that's where the business end of the mouse cursor is. And you can see, depending on different inventory items and actions that you can take, they each have their own little mouse cursor that you can then use within the game, and we'll see how those get used. So there's our tiles, we got our sprites, and we have a menu file. Now the menu is another XCI configuration, and here we can see the same sort of thing. Now if we just take a closer look at this XCI language, it's very simple. All it is again, like with the hex files, we have pound or hash, whatever you want to call it, characters denoting where comments are. But then outside of that, the first word we see in there is going to be a key, and the key has a special meaning, sort of has its own opcode, if you will, within the bytecode that we compile to. And then we give it a set of parameters. In some cases here, if it's a file name, we're within the SDK, we're going to be opening that file and then processing that and getting everything out into a binary form for the engine to deal with. But here in the menu, we can see we're defining a bunch of stuff here. We're defining a background color. We're saying the back, and we're using, in this case, numbers to say, all right, color 1, which is white, that's going to be the background color for the menu text. The foreground color of the menu text is going to be 0 or black. If we sort of look at, I don't have much of, I don't think I have any of the any of the characters. You'll see here in my spreadsheet a gap from 32-126. That's because those tiles are reserved to be the ASCII character set. So I just took the basic, the default font for the X16 and just reuse those tiles. And if we go into my tiles definition, we'll go in there and we'll see here there's not a lot of comments around them, but you'll see 6 for the background, which is the familiar blue, and then 1 for the foreground, which is the white, which is the default when you're using the X16. And so what we want to be able to do is replace what colors are used for 1 and 6. And if we go back to that palette where I sort of illustrate that out, the menu actually uses palette offset 11. And here we can see we've replaced color 1 with 0. So that which is our foreground color. So we want black text on a white background, and then color 6, if we go out here, we'll see that FFOF, that's white. And so now we've got basically we blew away the original white from the palette because it ends up over here, and now we have 2 blacks. So there's no blue on this palette, but that's okay. Basically, this palette offset's only going to be used for menu text. And that way it's be white on black. Then we can see we have other palette offsets here for text styles. And if we go back to that menu, we'll see down here we're defining text styles where we want to have something we call text style 1, which will be black on white, or rather white on black. And that's for text that appears in the text bar, text field at the bottom. We'll see what that looks like in a minute. And then there's yellow on black and light blue on black. So 3 different types of text that can appear in this text field at the bottom of the screen. And then a bunch of other things. We've got controls and about, which are sort of these help screens. I haven't actually shown these in YouTube games. So what I'm going to do is, now that I've got the game built, let's just jump into actually running it. So to do that, I'm going to call up my handy dandy X16 emulator, and I am going to then give it as a PRG file that was it? Nope, I'm sorry. Back to engine, and that was XCI.prg, and run that. And there we go. Hey. So here's the start screen. We'll look at how the start screen gets set up later. Anyway, I can just click and it gets rid of the start screen immediately. And here we can see that menu bar like we saw before. It's black text on a white background. And as we'll see up here in the menu configuration, when I bring that over, we define a some basic like tiles that we use for different things of the menu, different parameters, and just so like here, like the left corner, right corner, we use tile 2, and we flip it horizontally for the left corner, because if we look here at tile 2, back up here, we can see it's a little rounded corner, and it's rounded on the upper right side. So we use it as is here for the right corner, number 2, 2H, which is tile 2 flipped horizontally, and there it is over there in the right corner. And then we can see down here we define what are the menu items that we support for this game. And here for this one I'm supporting all the possible menu items. Now these are predefined menu items you can either use or not use in your game. We can see here I click on the file menu and I get new game. You gotta have new game. Nothing's gonna work without new game. You gotta at least have that. But then I have load game and save game as. These 3 right now in the current beta release are not supported. There's an issue I'm having with actually saving binary data from assembly. We're going to work that out hopefully before the next beta release. We can see here we've got a sound menu. We can toggle whether we hear the music or not. The other thing, the main thing we don't have in this first beta release is sound effects. There's no sound effects right now. You can still play with, enabling or disabling it. All it does is just change that little radio button, or checkbox rather, and you can have a little fun with that. But the music one will actually work. You can turn off the music on the example game if you want to. And then here in the help menu, we can see we have controls and about. As we can see here, we're defining that menu. We say, okay, within the help menu, we're going to have the controls. Then we're going to have a divider, which is the div menu item, and then the about menu item. And those have special things. Those also relate to these keys down here, where say, all right, well, for controls, I want to display a tile layout, and so we call it mygamehelp.text. So if I click on controls, there it is. And we can see here I got a mix of text and graphics in there, and it's all just tiles. What this my game help.txt is just a big tile map, and if we go over here, you can see there's the third language that I use for developing these games, which is really just for this specific purpose, for being able to, oops, I am going all over the place. Let me get rid of this. So here, for a tile map that is mostly text, where it's not just all graphical, it makes sense to be able to just easily just type out the text that you want to see. And then we have sort of escape codes for the graphical things that aren't represented by ASCII characters. So here, like for this little suitcase icon, this requires 4 different tiles to render, and we can see here we have tile 20 and 21, and then each of those flipped horizontally, because you'll notice that this is perfectly symmetrical. So this tile is the same as this tile, just horizontally flipped. Same with these two. So it's really just 2 tiles and then a mirrored image of each other. So we can help save some of the RAM, the video RAM, by doing things like that. Having tiles that we can easily flip. You notice here we do the same thing with this push pin, and the eye. You'll notice over here the eye. It's just one tile, tile number 22. If we take a look at that, tile 22, it's just that one corner of the eye. But if you take that one corner and flip it around each way, you can create one big eye that is horizontally and vertically symmetrical. So really save a lot of memory doing that. At any rate, so that's what we have. Now we can just click on here to get rid of it. The only other application we have for this sort of tile layout is the about, and we can see here even simpler. Oops, we'll get to diplomats later. Commander X16. There we are. And this one you can see it's all text, with the exception of we're using those nice rounded corner characters. But as you can see, like in the last one, we are flipping it each way so that we're getting that rounded bit in every possible position. And that's pretty much how you do the tile layouts, and that's all you really use them for in this game. Are for that sort of online help that you can bring up at any time. So again, what else we have in the menu? We have the toolbar definition. So the toolbar is something, again, hey, if we go back and look at the help, how do we bring the toolbar out? Oh, well, mouse down to the bottom to show the toolbar. Oh, well, thanks. And then, oh, that's what I was seeing the toolbar? Oh, okay, thank you. So scroll down there. Hey, look, there it is. So there's that inventory. And there's the walk and the run, look, use, talk, strike, and the pin. The pin, I can put that down, and then the toolbar doesn't go away. I take the pin back out, and then you can see it goes away once I mouse out of it. So that's what the toolbar does. And here I can define which tools I'm going to support in my game. I actually don't really support the strike. We'll see later on. I never have any support for the strike tool in there. It's a very non-violent game that I created, for example. But obviously, in a lot of games, you may need to resort to extreme measures. So, but for each of these, you can define them however you want. These are sort of suggestions of the types of things you do in adventure games. But these are really arbitrary, so you can redefine walk to be whatever you want. You could have some other sort of special, like the old Scum VM engine games like Maniac Mansion. They had like a taste action was one of the main things you could do. So you could make these be use whatever graphic you want to indicate, like the taste had a big tongue. So you could replace strike with taste if you wanted. It doesn't matter. So however you want to define these, you can define them here, say what tiles are going to show up in the toolbar, and then for the inventory, I click on that, and we can see now there's a new control that comes up in place of the scroll bar. This is their inventory control, and we can see here we have icons for the things that are in inventory. By default, we'll see in this game we have some money, we have $100, we have a pair of keys, and we have a phone. And that's it. That's what you start the game with. And if we look here, we're defining inventory with this mygameinv.xci, and that's it over here. And now we can see, yeah, oh, here's all the different types of items we can carry. And we can see here that, yep, by default we have the 100 money, we have 1 keys, 1 phone, and 0 of all the other types of items that we can collect in this game. And if you've seen the other YouTube video, you can see, you've seen how we acquire each of those items going through. Now these, you could have up to 127 unique types of items in your inventory, and you can use those however you want. And then up above here, we have some keys that help you define how the inventory is going, the look and feel, and sort of the window dressing of the inventory, what it's actually going to look like. And so all these little bits, as we go back here, we can see all these little lines we have, the fact that we have 4, the quantity is shown white on black with 4 digit, up to 4 digits, and then we have our scroll bar over here for when we have more items than we have room for in the control. We can scroll up and down through the inventory. And so yeah, we have all of that available to us, and you really have a lot of latitude in terms of how you define the look and feel. Like, you could use a single tile and that's it, and then all you have is just a bunch of tiles down in this area for selecting which item you want to use at a given time. You can really play around with that and do a lot of different stuff. All right, so pulling back up through the top of the stack again, and so we saw there how the menu is. Then we see the title screen. On the title screen, as we had seen already, it's a very basic animation, and it has you say, all right, the title screen is going to be this XCI configuration file, and here it is. And there's not a lot to it. Basically, we say, all right, it's got a duration of 600 jiffies. Now, jiffy is a 1/60th of a second. It's the vertical sync rate of the VERA chip for display, and so we're always going to have a 60 hertz display basically for the X16. So we use that for the timing for the whole game, and so to just have something last 10 seconds, we just have a duration of 600 jiffies. So unlike the other levels that we'll see later, only the start screen has this sort of fixed maximum duration. But then what we exactly like we'll see in the levels, we define a background bitmap. Although in this case, the bitmap for the start screen will take up the full 320 by 240 display, as we can see right here. This is a 320 by 240, and you notice it just has this bit. It doesn't have some of the other things that we see when we start. Let me reset here, and oh, it's all. I'm gonna have to redo that. Yeah, so here now we've got like this by John Doe, and we got the little dude running out, and we've got these little butterflies that appear over him, and then we say, hey, hello, hey, why haven't you clicked out of this yet? So those are all things that happen during the start screen. And we can see here within the start screen configuration, we define the animation that occurs. And so there's just a single sequence. There's no triggers or anything like we'll see in the levels. This is just one sequence that happens for the start screen. The start screens are not supposed to be interactive, and they're just supposed to last a little while. So here we define an animation loop. We have the sprite frames. We say, all right, so sprite 1, we're going to use that for our little avatar figure, and he's going to use palette offset 0, so that default palette, and then he's going to cycle through these sprites right here, 1, 2, 3, and then 2, 1, 4, 5, 4. So as we can see, that's good for him. Just see those first 5 frames 1 through 5 are good for him just walking left. And if you show them in this sequence, he'll look like he's running nice and good, just like he does in Chase Fall. Then we define his initial position. We place him down over here at 16 pixels in and 200 down, so right about here. And then we place the tiles down here. Now, unlike here, remember we had the tile layout for the help where we could just type text in there. We can't do that within the actual game animations. Here we have to use these decimal ASCII codes for that. So you can just trust me that all these decimal values come out to the ASCII for by John Doe. And then here now we get into the actual timeline of the animation. You can see here in our animations we have waits. Those are also in jiffies. So we wait just 2 ticks. And then we start moving that sprite. Over here it says, so it means we're moving sprite 1 every 2 jiffies. So we're waiting to like 2/60ths or 1/30th of a second. And we're doing 68 times. We are going to cycle through these frames. And each time we go to the next frame, we're going to be moving the sprite 2 pixels to the right and 0 pixels down. So it's just be going in a horizontal line like we see him just running across the bottom. And then what we do is we just wait 136 jiffies. That's how long it takes for him to get across there, which we can calculate just by multiplying 2 by 68. So 68 frames, 2 jiffies per frame, 136 jiffies. And then we render some tiles. And we can say here, we're going to use palette 0, and then we're going to add this coordinate. Now these coordinates, unlike the sprite coordinates where these are based in pixels, the tile coordinates are based on tile positions. So instead of having 320 by 240 to deal with, we have 40 by 30 to deal with. And so then we place, you can see here we take good old tile number 3, which if we go back over here, tile number 3 is that little butterfly. And we just place a bunch of those butterflies all around. We place 2 of them on one line, then we go down another line, and we do a butterfly, 2 blank tiles, and then another butterfly. It's in those 2 little blank tiles that our little sprite, the little guy, is going to be caught in between those. We just sort of time that all out. Using this language makes it easy to just sort of trial and error that. And then we just keep waiting until the very last second of this duration, and then we put up some more tiles to say, hey, hello, are you gonna click or not? We're ready to start the game. And then at that point, after that 600 jiffies, the 10 seconds runs out, it's just gonna go away anyway. And then we just get the screen here, the plain menu screen, and it's just waiting for you to select File, and hey, let's start a new game. And there it is. And if you've seen the videos before, you've seen what this looks like. We've got a little car down here, and we've got a flag. Those are all actually 3 different sprites. We got 1 sprite here that's moving for the flag, and we got 2 sprites here for the car, because the car is too big to fit in 1 sprite. So let's take a look. How did it know to do that? So if we go back here again to my game, and you know what, here, let's use that handy sound feature. Let's turn that music right off. All right. So now we're going to see what else did we do here. Okay, yeah, we knew we defined that title screen. Then the next thing we did is like, all right, and we're going to initialize the cursor. And the cursor, the sprite frame index we're using for the cursor is 0. And as we can see here, yep, there it is. There's that default cursor. I'm not hovering over anything that has a default action, so it's not. But oh, you'll notice here, I go over there, it changes. Over here, it changes. We know here these are these hotspots that we've defined for this level, so it changes away from that default cursor. But we'll see how that happens later. And then at that main, we see 3 zone files. We have 3 different zones defined for the game, And what we go into first when we do a new game, we go into zone 0, and then if we look here, how is zone 0 defined? Well, zone 0 just has 2 levels. And again, by default, when we start a new game, we go to zone 0, level 0. And levels, zone 0 is the first zone that we define in the main, and then level 0 for that zone is whatever the first level is we define in there. You don't have to be pedantic like I am and have all this special name in there saying Z0, level 0. You can call it whatever you want. And so anyway, let's take a look at that. Z0 level, oh, that's level 1, sorry. And what happened there? Okay, so zone 0, level 0. And now you can see, as we remember, we had this my game house.data. So what that is a raw data version of this image here. Now this is the PNG, so that we can actually render it right here. Now if we go back and look at that start, you'll notice that it's a bit shorter than this, because this one's only you see 320 by 200, as you can see down there, as opposed to this one, which is 320 by 240. Because in the levels, we have to have, as you can see, we have to have room at the top. We have 8 pixels at the top for the menu bar and 4 pixels at the bottom for this text field. And the text field, of course, you can see that goes away once you bring up the toolbar or then the inventory. So these are going to be shorter, and that also helps save on the memory. So we only need 4 banks of high RAM to store each of these bitmaps for the levels, and that makes it faster to go from level to level within the same zone. Now, to get from a PNG like this into a raw data format that the SDK can actually process. Right now, the SDK can't take PNG files directly. That hopefully maybe that will change in the future, but the raw data format makes it very explicit in terms of what kind of data we're taking in, and we're just doing very basic processing on it. Now, the nice thing is there's open source tools like GIMP, which I have right here. And here I have that same PNG file. You'll notice here this is a 320 by 200 PNG, and it's index color. And if I look at the palette, it's just 16 colors. That's how I designed this. But since I'm keeping it very simple, I just have a plain red house. It's got a flat blue sky and a few like gray things and some black and white things. And then I can save the rest of the palette for defining nicely random textured grass and pavement down here. So that's where I'm actually using most of my colors. But you notice here, there's no flag up here, there's no car down here, because those are added with sprites. And then also, if you'll remember, in that first level, if I just play it again, let's play it again. That's the nice thing about this. As you can see also, sometimes the mouse cursor does not like to cooperate in the emulator. If I do a new game, and there it is. So, yeah, we've got the car down there, we've got the flag waving. This is my house. See, hey, look at there, I put some tiles up over there saying, yeah, my house. So all that stuff can be added through the game animation. You don't have to have that in the background. You don't have to switch to a different level to do some simple overlays like that. You can do all that with the animation. So, going back to here we are. So, how do we define the animation? We already saw here for the top level, we're defining the bitmap for the background, which is this mygame_house.data. Anyway, yeah, you can get that really simply with GIMP by doing export as, and then select my file type, and you'll see down here you can export to raw image data, and the extension will be .data, and what that'll create are actually a pair of files, full, actually I'll have to look over here. So you'll notice here for the house, I have mygamehouse.data, which I reference up here in the configuration file, and there's myhouse.data.pal, and that defines the palette. And so when we load that palette into the game along with the actual bitmap itself, so that we can have, for each level we load, we have a custom 16 color bitmap. Makes it nice and easy to have a lot of diversity of color through the game, and there we have it. So yep, so we've defined here the flag waving sprite. We've got 8 different frames for flag waving, and we're defining sprite 2 for the flag, and we can look here at our sprites, and we'll go down here, and there's all those flags, and we just cycle through those, and we just sort of place it right here. 28250 places it right here at the top of the pole, and then we just let that start just going for 12 seconds. We only need to go for 12 seconds because we're not even going to be here that long, because this, as we saw with this very first level, it's just sort of a cinematic playback. There's no interaction to it, and so we do all that within what we call the first sequence. And the first sequence runs the first time you visit a level. So if we somehow were able to come back to this level, we would still see the things that happen in the init sequence, where we're setting up the flag waving and replacing the car. Over here you see the car is sprites 3 and 4, just sort of placed adjacently. But so we could come back and see those sprites still there, but only the first time we visit this level will we get this whole spiel. And so you can see here, what we do is 30 ticks or jiffies, which is half a second after loading. We start putting out the text, and we say, hey, text style 1, which is the white and black, hello, welcome to my game. And then we just go through here. We have little weights in there. We have some other things to sort of manipulate the way the text in there. We can scroll the text field. We can insert blank lines, and then we can clear the text field, so get rid of the text that's there and start over again from the top. But then as we keep going, if we just keep adding lines of text, it'll just keep scrolling up. And then here we can see here, after it says C, it overlays those tiles where it says my house right here. And then we go through and do a few more texts. We can see a bunch of wait 60s, so we're just giving a second in between showing each line, just so that the text doesn't come up too quickly. And then after the last text, we wait for 120 jiffies or 2 seconds, and then we have a go level 0-1, which is go level 0, go to level zone 0, level 1. Sorry, and that's how we get to the kitchen. As we can see here, we're already in there, and the kitchen is a little more sophisticated. We actually have some interaction in this level. So we go over here to zone 0, level 1. Somehow that top comment got doubled. I don't know when that happened, but here we go. It's the excitement of open source software. So here now we have a different background, has a whole different palette and everything. And we can see here the kitchen is very bare bones. As opposed to, we look in the game, we can see we've got coffee maker over here, we got some bananas over here. These are all tiles. Unlike the previous one where we sort of had everything in sprites, in this case, now we're just having everything in tiles. And these tiles are made to be placed right here, and it's we're not expecting the tiles to be animated. You could animate the tiles by replacing them, but they are harder to place, and you can't really move tiles around. Tiles can only sit within these 8x8 squares, this 40x30 grid that's on there. So they're not as good as sprites for actually doing any animation that involves movement. So yeah, so we've got a coffee maker, we got a coffee cup, we got some bananas, and so that's, as you can see, that's all in the init sequence. So we put the coffee maker there, and then we define a steam loop. We'll see here, like when we make the coffee by using the coffee pot, it makes some steam come up. And so those are the frames right there for the steam. And if we haven't taken the bananas yet, we place the bananas over there. If we haven't taken the cup yet, we place the cup over there. And then we sort of initialize a bunch of states. So states become very important in terms of the game mechanics. But we can see here, when I hover over there, that little hand comes up. That's the use cursor, because the first trigger that we define for these tile areas, all the triggers are based on the tile grid rather than pixel by pixel. And you can see the steam stopped already. I don't have enough time on that steam animation to last that long. I check some states, so if the coffee's been made and I'm already holding the carafe, neither of those things are true, but in that case I would have this little dialogue here, but I haven't made the coffee yet, so I want to go from this if to the corresponding end if. But it's not this, because we've got this block here, which happens if we're holding the carafe, and then this block happens if we're not holding the carafe. But here we see the end if, and I helpfully added a comment here. This is if the end of if the coffee's made. So the coffee hasn't been made when I first click on it. And in that case, it's clear, and it says, oh, okay, I'll make some coffee. And it waits 60 seconds. It shows the steam by making the sprite visible, placing it right there above the pot, and then kicking off that movement. So you'll get 30 seconds of steam after you make that coffee. After that, it's just going to be suspended animation steam at that point. And then it waits 2 seconds and then fills the carafe. And filling the carafe is a very simple animation, because all it's doing is replacing the tiles for this carafe from being clear and showing the being transparent, so you can see the blue of the wall behind through it, and we change it to an opaque brown for the coffee. And that's how we get these two tiles right here, 168 and 169. Those are the tiles that we're replacing over here to get the coffee. And then we say done, smells good, like we saw right there. Now, if we do this again, our state's changed, because now we've set the state coffee made, and now we'll execute this trigger again by clicking on that coffee maker again. And if the coffee is made, but I'm not holding the carafe yet, so I'm going to actually go into here, say, nope, not holding the carafe yet. I haven't set that state. So if not holding the carafe, it's going to go into here and say, oh yes, nice coffee, and let's find a good cup to pour it into, and then it will set that holding carafe state. And that's what I need. So I'll go ahead and do that again. So now within the game, I've basically picked up that carafe from the coffee maker. And then what I want to do is pour it into the cup. And we can see here, I have another trigger for clicking on the coffee cup with the use tool. And so that's why I still get that little hand cursor popping up when I'm over the cup. And here, say if the cup's not taken, I'll go into here. So I haven't taken the cup yet, but I am holding the carafe. So I'm going to skip over all this part, and it's going to go here. So yeah, if holding the carafe, yep, I'm going to do that. And so I'm going to get this text, sure, pour the whole pot. Let's bring that back up. And you can see here, and yes, look, now that steam has moved over here, just like we show over here. We've cleared the state. We're no longer holding the carafe. We no longer have made coffee. We can see the carafe went back to being empty and transparent. And now we've moved the position of the sprite, and then we're doing a new sprite movement. And just like that flag movement, there's no movement vectors, just staying in place, 0, 0. But it's every 12 jiffies, it's changing frames. And it will do that for 150 frames, so just 30 seconds. You've got 30 seconds to take the coffee. And you see, we've already passed that. We've talked enough. So then the next time, once the coffee's been made, if the cup hasn't been taken, but the coffee has been poured, you can see here, We're not holding the cup's taken. We're not holding the carafe, but the coffee has been poured. So we're going to go past that if, and we're going to start this sequence here. So if the coffee's been poured, we're going to clear, and we're going to say, go ahead, take it with you, and we're going to get rid of the steam and the cup. All that's going to go away. And there it is. So it all goes away. We got rid of that steam. We got rid of the steam animation, the sprite animation, and those tiles for the cup. Those are all gone. So you can see here we've replaced those tiles by and there's just two tiles on two separate rows. So at 2112, we changed that to transparent. 2113 made that transparent. So both those tiles are gone. And that's it. And then we do a get item of coffee. And so as we remember here in the inventory, we defined coffee as one of those items. We can have up to one coffee, and it has these tiles, and it has here a special cursor, 26, which is, we go back up here, it's like, yeah, 26, hey look, there's a mouse cursor just for the coffee. So we've defined all of that for our game, and we've defined these 4 tiles that will appear in the inventory. So as we go in there it is. And there's our coffee, and we've got one of them, and we can click on it, and we can like pour coffee on the bananas, but we don't have a trigger for that, so nothing happens. So let's go back and say, hey, we want to use the bananas. Now we can see here that instead of having the default cursor, I've got that use cursor everywhere I go. So if I click somewhere where I can't use, it doesn't do anything. But I can use the bananas. And there we go. Go ahead and take the bananas. As we'll see if we go back here. Lost my place. There we are. We have a trigger for the bananas. It's default. So if we hadn't selected inventory item, that use cursor would have come up by default as we had seen before. And it goes ahead and takes the bananas, and it removes the banana tiles. Here we had 4 tiles, so the first row of 2 and the second row, zero those out, and then we add 3 bananas to our inventory. And so we'll see here, look in the inventory, and there they are. Bananas, count 3. Very good. And then we can see here we have a default action to walk through the doorway. And so we can just do that. But say we don't want to do that. If we want to do something else, say we want to look at the doorway before we walk through it. In order to do a look, we'd have to go down here to the toolbar, select a look, and then click on that. Oh, I'm not talking. What am I talking? All right, when I look, and there. So now we thought, hey, that's the doorway to the foyer. And just as we see down there, that's what happens. But in order to get that trigger to happen, we had to go and select it explicitly. But here, now, if we go back to the default behavior, we'll do the default. So the first trigger for this area, which is, you see here, basically tile area 26 to 623, which is about roughly here. So we can see here, every time we enter that rectangle, we get the walk cursor. So we click on that, and as we'll see here, if we do the walk tool on there, we will go to level 10, which is zone 1, 0. So this is the point where it will go back to disk, which on the real hardware will be SD card. Here on the host, it's just my host file system. It'll go ahead and load all of zone 1, all the levels for zone 1, and then load level 0 from that into gameplay. And there it is. So I'm not going to go any further into it right there. You can see how the rest of the game looks in the walkthrough video. I'll have all that linked in here. But if you're interested in this, right now, as of this moment, we are in, it's a royal we, it's just me. I'm one guy. I have beta release for the engine. You can go ahead and try making your own game. You can play around with the example game, expand on it, whatever you want to do. to do your part of beta testing. Or if you just want to get right to work making your own game, that is awesome. You want to get together with your friends, and you got one guy that likes to make music. Oh, that's what I forgot to show. So yeah, let me, before we leave, wait, there's more. So the start screen, as we saw, we had My Game Start data and My Game Start VGM. Well, what's a VGM? Now, VGM is a video game music file. And there's a lot of ways of creating video game music files, but you got to create one that has the sound hardware, that takes advantage of the sound hardware that the X16 has. And right now for emulation, all we're supporting is the YM2151. So luckily Deflamask supports that, because a bunch of old Sega video games, arcade video games, use that YM2151 in conjunction with a pulse code modulated DAC, just basically having sort of sampled sound effects that you could add along to the music. We're going to have something similar for that for the X16. It's not available yet in emulation, but I know that will be part of the VERA chip, the VERA daughter board rather, and and that will give us the ability to have either music that has sort of samples added to it, or my intention is eventually when we implement sound effects, rather than using an FM synthesizer like the YM2151, we'll just use the PCM to just have basic sampled sound effects, little square wave type sound effects, very nice old school type video game sounds. Anyway, so here Deflamask, this is I try to create as little original content as possible so I could get this example game out the door and get to beta release as soon as possible and start creating an actual game. That's my goal, is to create like a real full-scale game with this engine. So I just reused the windscreen. I sort of switched it around. The very final music you hear in Chase File, that's the very first music you'll hear in this example game. As I play it here, you can see it uses all 8 voices of the 2151, and so Deflamask is really how I composed the whole piece, was just by sort of tracking it out in here. And what Deflamask allows you to do is save a file as a VGM, just like how GIMP can save a raw data file. Deflamask can save a VGM, but there's other ways of creating VGMs. You can create VGMs by hand. There's other authoring tools out there, and but Deflamask is easy in that it lets you sort of load 2151 instruments and other example tracks and things, and you can sort of cobble together your own music based on the examples of others, so that you're not starting from square one and having to find all your instruments from scratch. That's no fun, unless that's the thing you're into, in which case I'm sure it's lots of fun. It's not for me. Anyway, so that's all the stuff that I'm going to show you in this video. I really do hope you go in there. Again, go back to GitHub, read through this README. It's a lot, I understand. It's a lot of stuff in there. The main README file is very large, but it's very comprehensive. It talks a lot about it. It goes through those 2 levels, and the start screen, like I showed you, goes through that sort of same level in detail. You can go back and read through that if you want. And then at the very bottom here, you can see there's a couple of other pieces of documentation that I created. Also very helpful. One, I'll put it in a new tab here, is the XCI configuration file syntax. That's a more concise guide. If you want to look at this XCI file for creating animations and whatnot, and the other top-level configuration files, here I created a very sort of formalized API for the SDK, all the different keys and the arguments for them, and just get into very basic detail how you actually write within this very simple, like I call it, a high-level assembly language. So you have that to go through, and then if you want to get deeper into the example game, I'm not going to go through this myself on a video, but I took the time to write it all out in this nice long file of going through all the other zones. Like here I start talking about Zone 1 Level 0 like we're in right now. So you can read more about that in this appendix. And it goes through the entire game all the way to the end, and then has a link back to that walkthrough video. And and that walkthrough video will again show you sort of in real time what it looks like to play the game. Anyway, I hope you're still watching. This has been an extremely long video for me. I don't usually talk during these videos. Let the games do the talking, but this required some talking, and I'll probably do some more talking type videos. But anyway, thanks. And if you like this content, if you like retro gaming, if you are really interested in the X16, then by all means subscribe to my channel and check out some of my other videos. I've done a bunch of little demos on here. And you can see go back through the entire history of developing Chase Vault, which is another fun game that I've already created and is already out in beta release. And you can go ahead and play that today and hopefully enjoy that and learn from it. All the code's open source. I'm not selling anything. This is not a commercial enterprise for me. So please go out and support your local coder, and I thank you again. Bye-bye.